So in this video, I'm going to show you 5 different examples of solving a word problem that uses a system of equations. So for each of these, what we're going to do is we're going to be coming up with 2 separate equations, right, that relate the unknown quantities, and then we're going to solve that system. So sometimes you'll see me drawing a picture. Seems to help me sometimes. And then I'm hoping that you'll kind of get a feel for these. They should all have a similar feel. And then again, I'm going to just show you some strategy. So here we go. Here's our first example. A concession stand sells programs for $3 and banners for $8. One game, it sold $156 worth of merchandise, and it sold a total of 26 items. How many of each item did it sell? So strategy is, first we're going to start with a question mark and figure out what the unknowns are, and then we're going to choose letters for them. So how many of each item? Well, what 2 items were there? Right, there were programs and banners. So I'm going to let P stand for the number of programs. And here's another strategy right now. Oh, here. What are the unknowns, right? Programs and banners. Number of. That's kind of important too. So number of programs, number of banners. So what letters should we use, right? Well, let's use P for programs and B for banners. And then now we have to come up with our 2 equations. So the first equation is often a relationship about the total number. So what's the total number here? 27. The total number of items. So that equation then would be, right, number of programs plus the number of banners is the total number of items sold. The second equation is often about a percent or an amount. Right? In this case, it's about money. Okay. So the left side is straightforward, but sometimes we'll need to pay attention on the right side to make sure that all 3 of the terms in the equation are talking about the same thing. Okay, I'm sure we'll have an example here in one of our 5. So again, in this example, the second thing we know about is money. So let's think about that. So each program sells for $3. So there's $3 per program, so times P. And then plus, so this is all money. And then $8 for every banner. So 8 times every banner. And altogether, we had a total of $156. This is $3 for every program, $8 for every banner, right, all together. So all of those are money. Now we are going to take these 2 equations, put them together, and solve our system. So P plus B is 27, and 3P plus 8B is 156. I think I'm going to do substitution. So I'm going to take my top equation and solve it for P. So P equals 27 minus B. Substitute that into the second equation. I'm going to use a calculator because those math numbers are going to get big here. So 3 times P, which is 27, minus B plus 8B equals 156. Distribute your 3. So 81 minus 3B plus 8B equals 156. Let's see, negative 3B plus 8B, that's 5B. I'm going to subtract 81 from both sides. I'm kind of running out of space, so I'm going to do it down here. So 156 minus 81 is 75. So 5B is 75. So divide both sides by 5. Looks like B is 15. So 15 banners. And now, right, we have to tell both how many of each type. So we know 15 banners. To find out how many programs, remember there were 27. You can plug it into either equation, but it's kind of nice right here Number of programs is 27 minus the number of banners because there were a total of 27 items shown. So P equals 27 minus what we now know is the number of banners. So it looks like that is a 12 programs. Okay, let's try the next one. So let's say I'm going to start a coffee roasting business and I want a blend that I can sell for $8.80 per pound. Gosh, that's pretty cheap. I have beans that are $12 per pound and some that are $7 per pound. How many pounds of the different coffee beans should I use if I want to roast 100 pounds of coffee? Gosh, I don't know. What are my unknowns, right? How many pounds of each type? So what would we do? Let's say, so X can be the pounds of $12 coffee, and Y can be the pounds of $7 coffee. Okay, so what's my first equation? It'll be just about how many pounds of coffee, right? The actual amount that we have. So we have X pounds of the expensive stuff plus Y pounds of the cheap stuff. And how many do I want altogether? 100 pounds of coffee, right? So there's just how much coffee. The other one is going to be about money again. So let's think about how much money is going into, right, this coffee. And so another way, I said I was going to draw a picture. Here's what this picture looks like. Right? So this is my $12 a pound coffee and my $7 a pound coffee, and I'm going to end at $8.80 per pound. And this amount here is there's X pounds of the expensive stuff, Y pounds of the cheap stuff, and when I'm done, I want 100 pounds. Right, so one equation is X plus Y equals 100. The second equation is about how much money is going in, right? So it's $12 for every pound of the X, so that's going to be 12 times X. That's how much, right, value is being contributed by the expensive coffee. 7 times Y for the last, right, for the cheap coffee. And then when I end, I want 100 pounds that's worth $8.80 per pound. So 880 times 100. So dollars per pound times pound, dollars per pound times pound equals dollars per pound times pound. Okay, so they all have the same, right, we're coming up with the same idea. Okay, elimination, how about that? Let's multiply the top equation by -7. Think about what that's going to get rid of. So now I have -7x minus 7y equals -700. Bottom equation just stays the same, except I'll do that multiplication there. So 12x plus 7y equals, let's see, 880. Okay. Add those two together. So 5x, the y's add away. We get to my equal sign. 880 minus 700. I'm going to use my calculator because I don't trust myself. That looks like 180. And then divide both sides by 5. So x equals 180 divided by 5. That looks like 36 pounds of $12 coffee. And the y value then, how much of the $7 coffee would I need? Well, I'm just going to grab this equation right here. Remember, I wanted a total of 100 pounds. So if 36 is the expensive stuff, that means I need 64 pounds of the $7 coffee. Okay, so let's do 3 more. So here's a juice blend. So if you want to draw that picture kind of like we had before. So juice blend, I want it to end at 25% juice. So when we end, I want it to be 25%. And what I'm going to start with is I have 40% and a 10%. How many type of each should I use? So those are your variables, x and y. And I want to end at 30 liters. Okay. I think you can do it. If you want to hit pause and try this one by yourself, you can get the system set up and then check in and make sure you've got it right, and then hit the pause again. So my unknowns, x, number of liters of the 40%, and y will stand for the number of liters of the 10%. So then our system, x plus y equals 30. And then we have the equation that deals with the percents. So 40%. So remember when we put percents into equations, they go in like a decimal. So 0.4 times x plus 0.1 times y equals, again, it's percent times amount plus percent times amount equals percent times amount. So it's kind of saying how much actual juice is in each of the vats. And so percent, so 25% times 30. Okay, what are we going to do for that one? Should we do substitution again? Okay, so solving, how about for y? So y equals 30 minus x. We'll take the 30 minus x and substitute it in for the y on the second equation. 0.4x plus 0.1 times y, now being played by 30 minus x. And then 0.25 times 30. I think that's 7.5. Yep, 7.5. So one equation, one unknown. So distribute. We're going to solve for x first, it looks like. So 0.4x plus 3. 0.1 times 30 is 3. Minus 0.1x equals 7.5. I know there's lots of decimals. It's okay. If you know a way to get rid of them, go ahead and do that. I'm just going to live with them because I'm going to use my calculator to help me out here. I'm going to subtract 3 from both sides, and I'm going to combine these two x terms on the left. So I have 0.3x on the left, and the right, once I subtract 3, looks like a 4.5. So dividing by both sides by 0.3, right? So x equals 4.5 over 0.3. So that looks like it is 15. So 15 liters of the 40% juice. And then I know I wanted a total of 30 liters altogether, right? A total of 30 liters. So if 15 of it's 40%, that means I also have 15 liters of the 10%. Okay, so there's your answer. Okay, one more blending example. Oh dear. Okay, so I think I need a bigger picture on this one. So I have 10 gallons of a saline solution that is 33% salt saline. So I'm going to go ahead and draw what I'm starting with. So I have 10 gallons, that's how much, and it is 33%. How much should I drain minus how much? I don't know. That's my x. But the percent that I'm draining is also 33%. This might not actually be a system. This might just be a picture here. And replace with water. So now I'm going to add back in how much. I'm going to top it back off, right? So if I take out x gallons, I'm going to add back in x gallons. And it's going to be straight water. So this is a percent saline, all right, percent of the salt. So I'm going to add back in 0% because it's water to obtain, so that's at the end, back to my 10 gallons, and I want it to be 25% salt. Okay, it's not a system, it's just a straight up equation. Here we go. So everything is dealing with, right, how much salt I've got going on. So I start with 10 gallons at 33%. I'm going to take away X gallons at 33%. I'm going to add in or add back X gallons at 0%. And when I'm done, I want 10 gallons at 25%. Okay, well, let's see. What do we get? Let's see. 10 times 0.33 is 3.3 minus 0.33x. 0 times x is 0, so that just stays. And then so there's my equal sign, and then 10 times 2.5, 10 times 0.25 is 2.5. And we're going to solve for x. So let's subtract 3.3 from both sides. So negative 0.33x equals, let's see, I've got 2.5 minus 3.3. So it looks like negative 0.8. So I would divide both sides by negative 0.33 to get the x by itself. So this is how much we have to drain and then add back in. So I'm just going to go straight to divide by negative 0.33. Oh, and remember, since I want to divide by the negative amount, you use the change sign key down here at the bottom of your calculator. And that looks like 2.4242. So we'll say that's approximately 2.42 gallons. Okay, last example. I like to sometimes use the system method with my distance equals rate times time type questions. So I'm going to make a table with my DRT. Let's see, maybe I can fit everything down here. And then I write an equation for each line and solve that system. So let's say 2 cars leave Salt Lake City traveling in opposite directions. So we'll just say north and south. One car travels at a speed of 80 miles per hour. So I'll put that in the rate of one of them. And the other one travels at a rate of 64 miles per hour. How long until they are 504 miles apart? Well, oh, they're going to travel at the same time, right? So these are both T's. Because they both travel for the same time. And then when they get to be 504 miles apart, and then we'll know what they are. And this, I guess, this one's not really a distance equals rate times time one either. I know that, so distance equals rate times time. So the first car, the car traveling north, is going to go 80 times t miles, right? Its rate times its time. The second car, the car heading south towards Provo, is going to go 64 times t miles, right, in the time that it has. And altogether, the time it's going to go is, or I'm sorry, the distance it's going to go is 504 miles. So the distance the north car travels plus the distance the south car travels equals 504. Right, so this is the distance for the north car plus the distance for the south car equals the total distance. Oh, so it is just one equation this time. So add those two together. What is that? 144t equals 504. So 504 divided by 144. Right? Divide both sides by 144 to get the t by itself. So the time that they would be traveling is 3.5 hours. So some of these, I guess you don't actually have to have a system once you get going. But the table and the pictures that we use for systems can still be useful.